The National Electrical Code, or NEC, mandates specific guidelines for electrical installations to ensure safety and prevent hazards. One crucial aspect of electrical safety involves correctly sizing circuit breakers for appliances, such as ovens. Considering the question regarding a double-stacked oven with a nameplate rating of 7.2 kVA currently connected to a 50 amps double-pole branch circuit, the NEC mandates that the 50 amps breaker be replaced with a 40 amps breaker. NEC Section 210.19 addresses branch circuit ampacity and dictates that the maximum load on a branch circuit shall not exceed 80% of the circuit's ampacity. For a 50 amp circuit, the maximum allowable load is 50 amps multiplied by 0.8, which equals 40 amps. This 80% rule is a fundamental safety measure intended to prevent overloads and potential overheating of the circuit wiring. The oven's nameplate rating of 7.2 kVA indicates the oven's power consumption. To determine the current draw, the following formula is used: current equals power divided by voltage. Assuming a standard voltage of 240 volts for the oven circuit, the calculation is as follows: current equals 7.2 kVA divided by 240 volts. Converting 7.2 kVA to watts by multiplying by 1000 gives 7200 watts. Therefore, current equals 7200 watts divided by 240 volts, resulting in a current draw of 30 amps. This means the oven, at full load, consumes 30 amps. The purpose of the breaker is to protect the circuit from overcurrent conditions. The breaker must trip and interrupt the circuit if the current exceeds the breaker's rating, preventing overheating of the wires and potential fire hazards. The manufacturer's recommendation to use a 40 amps breaker for the oven is also a crucial safety consideration. Appliance manufacturers conduct thorough testing and analysis to determine the appropriate breaker size for their products. Their recommendations take into account various factors, including the appliance's operating characteristics, potential surge currents, and the need to provide adequate protection against overloads. Using a breaker with a higher rating than recommended, such as a 50 amps breaker in this case, could compromise the circuit's protection. If an overcurrent event occurs, the 50 amps breaker may not trip quickly enough or at all, allowing the wires to overheat and potentially causing a fire. The 40 amps breaker provides a safety margin to accommodate the oven's operating characteristics and potential surge currents. Firstly, it's important to understand the concept of ampacity, which is the current carrying capacity of a conductor. Ampacity is determined by factors such as the conductor's material size, insulation type, and the ambient temperature in which it is installed. The NEC provides tables and guidelines for determining the appropriate ampacity for different types of conductors under various conditions. Secondly, the 80% rule specified in NEC Section 210.19 is intended to prevent continuous overloads on branch circuits. A continuous load is defined as a load that operates for 3 hours or more at a time. For continuous loads, the maximum load on a branch circuit is limited to 80% of the circuit's ampacity. This ensures that the circuit wiring does not overheat due to prolonged high current draw. Thirdly, in addition to the 80% rule, the NEC also requires that overcurrent protection devices, such as circuit breakers, be sized to protect conductors against overcurrent conditions. Overcurrent is defined as any current in excess of the rated ampacity of the conductors. Overcurrent protection devices are designed to trip and interrupt the circuit when an overcurrent condition occurs, preventing damage to the conductors and reducing the risk of fire. Fourthly, the NEC also addresses the sizing of overcurrent protection devices for specific types of equipment, such as motors and appliances. For example, NEC Section 430 covers the overcurrent protection of motors, while NEC Section 422 covers the overcurrent protection of appliances. These sections provide specific requirements for sizing overcurrent protection devices based on the equipment's characteristics and operating conditions. Fifthly, it is essential to consult the appliance manufacturer's instructions and nameplate information when determining the appropriate overcurrent protection for an appliance. The manufacturer's instructions typically specify the recommended breaker size for the appliance, while the nameplate provides information about the appliance's power consumption and other electrical characteristics. Failing to follow the manufacturer's recommendations can result in inadequate protection and potential safety hazards. Sixthly, it is also important to consider the voltage of the circuit when calculating the current draw of an appliance. The formula for calculating current is current equals power divided by voltage. If the voltage is lower than the assumed 240 volts, the current draw will be higher, and a larger breaker may be required. Conversely, if the voltage is higher than 240 volts, the current draw will be lower, and a smaller breaker may be sufficient. Seventhly, in some cases, it may be necessary to upsize the conductors in a branch circuit to accommodate a larger breaker. For example, if the oven's nameplate rating is higher than 7.2 kVA, it may be necessary to use larger conductors to ensure that the circuit can safely handle the increased current draw. The NEC provides tables and guidelines for determining the appropriate conductor size for different ampacities. Eighthly, it is always advisable to consult with a qualified electrician when installing or modifying electrical circuits. Electricians have the knowledge and experience to ensure that electrical installations comply with the NEC and other applicable codes and standards. They can also identify potential hazards and recommend appropriate solutions to ensure electrical safety. Ninthly, in addition to the NEC, local electrical codes and regulations may also apply. Local codes may have more stringent requirements than the NEC in some cases. It is essential to be aware of and comply with all applicable codes and regulations when installing or modifying electrical circuits. Tenthly, it is important to regularly inspect electrical circuits and equipment for signs of damage or wear. Damaged or worn wiring, loose connections, and other electrical hazards can increase the risk of electrical shock, fire, and other safety hazards. Regular inspections can help identify and address potential problems before they become serious. In summary, replacing the 50 amps breaker with a 40 amps breaker for the 7.2 kVA double-stacked oven is mandated by the NEC. This requirement is based on the 80% rule for branch circuit ampacity and the need to provide adequate overcurrent protection for the circuit wiring. Consulting with a qualified electrician is highly recommended to ensure that the electrical installation complies with all applicable codes and standards and that all safety considerations are addressed. Furthermore, several other sections of the NEC could be relevant, depending on the specifics of the installation. For instance, Article 110, Requirements for Electrical Installations, provides general requirements for all electrical installations, including those for dwelling units. This article covers topics such as wiring methods, grounding, and overcurrent protection. Article 220, Branch Circuit, Feeder, and Service Calculations, provides detailed instructions for calculating the loads on branch circuits, feeders, and services. This article is essential for determining the appropriate size of conductors and overcurrent protection devices for various electrical loads. Article 250, Grounding and Bonding, covers the requirements for grounding and bonding electrical systems. Proper grounding and bonding are essential for electrical safety, as they help to prevent electrical shock and fire hazards. Article 300, Wiring Methods, covers the requirements for various wiring methods such as cable, conduit, and raceways. This article specifies the types of wiring methods that are permitted in different locations and under different conditions. Article 310, Conductors for General Wiring, provides information on the ampacity of conductors and the requirements for conductor insulation. This article is essential for selecting the appropriate size and type of conductors for electrical installations. Article 400, Flexible Cords and Cables, covers the requirements for flexible cords and cables. Flexible cords and cables are commonly used to connect appliances and other portable equipment to electrical outlet. Article 422, Appliances, provides specific requirements for the installation of appliances, including ovens. This article covers topics such as overcurrent protection, grounding, and wiring methods. Article 630, Electric Welders, covers the requirements for electric welders. While this article may not be directly relevant to the installation of an oven, It provides valuable information on the principles of overcurrent protection and circuit sizing. Additionally, the National Electrical Manufacturers Association, or NEMA, publishes standards for electrical equipment and systems. These standards provide guidance on the design, construction, and testing of electrical equipment. Consulting NEMA standards can help to ensure that electrical equipment is installed and operated safely. For example, NEMA Standard WD6 Wiring Devices Dimensional Requirements provides information on the dimensions of wiring devices such as receptacles and switches. This standard can be helpful when selecting wiring devices for use in electrical installations. NEMA Standard PB1 Panel boards provides information on the construction and performance of panel boards. Panel boards are used to distribute electrical power to branch circuits. This standard can be helpful when selecting and installing panel boards. NEMA Standard ICS2 Industrial Control and Systems provides information on the design and operation of industrial control systems. While this standard may not be directly relevant to the installation of an oven, it provides valuable information on the principles of electrical control and safety. Furthermore, the Institute of Electrical and Electronics Engineers, or IEE, publishes standards for electrical engineering. These standards provide guidance on the design, construction, and operation of electrical systems. Consulting IEE standards can help to ensure that electrical systems are designed and operated safely and efficiently. For example, IEE Standard 141, Recommended Practice for Electric Power Distribution for Industrial Plants, provides guidance on the design of electric power distribution systems for industrial plants. This standard can be helpful when designing electrical systems for commercial buildings. IEE Standard 142, Recommended Practice for Grounding of Industrial and Commercial Power Systems, provides guidance on the grounding of industrial and commercial power systems. Proper grounding is essential for electrical safety as it helps to prevent electrical shock and fire hazards. IEE Standard 519, Recommended Practices and Requirements for Harmonic Control in Electric Power Systems, provides guidance on the control of harmonics in electric power systems. Harmonics are distortions of the sinusoidal waveform of electrical power. Excessive harmonics can cause problems with electrical equipment and systems. In addition to the NEC NEMA standards and IEE standards, there are also various other resources available to help ensure electrical safety. These resources include training programs, certification programs, and online resources. For example, the National Fire Protection Association, or NFPA, offers training programs on electrical safety. These programs can help electricians and other electrical workers to stay up to date on the latest electrical codes and standards. The International Association of Electrical Inspectors, or IE, offers certification programs for electrical inspectors. These programs can help electrical inspectors to ensure that electrical installations comply with all applicable codes and standards. There are also many online resources available on electrical safety, such as websites, forums, and blogs. These resources can provide valuable information and support to electricians and other electrical workers. In conclusion, ensuring electrical safety requires a comprehensive approach that includes compliance with the NEC, adherence to NEMA standards and IEE standards, and participation in training and certification programs. By following these guidelines, electricians and other electrical workers can help to prevent electrical shock, fire, and other safety hazards. Remember to consult the specific requirements of the NEC edition adopted by the local jurisdiction. The NEC is updated every 3 years, and local jurisdictions may not adopt the latest edition immediately. It's also worth reiterating the importance of not exceeding the 80% rule for continuous loads on branch circuits. A continuous load is defined as a load that operates for 3 I/Os or more at a time. For continuous loads, the maximum load on a branch circuit is limited to 80% of the circuit's ampacity. This helps to prevent overheating of the circuit wiring. When calculating the load on a branch circuit, it is important to consider all of the appliances and equipment that will be connected to the circuit. This includes not only the oven but also any other appliances, such as refrigerators, dishwashers, and microwaves. It is also important to consider the lighting load on the circuit. The NEC provides tables and guidelines for calculating the lighting load based on the square footage of the area being lit. In addition to the load calculation, it is also important to consider the voltage drop on the circuit. Voltage drop is a decrease in voltage that occurs as electricity travels along a conductor. Excessive voltage drop can cause appliances and equipment to operate inefficiently or not at all. The NEC provides guidelines for limiting voltage drop on branch circuits. To minimize voltage drop, it is important to use the appropriate size conductors for the circuit. The NEC provides tables and guidelines for determining the appropriate conductor size based on the ampacity of the circuit and the length of the conductors. It is also important to make sure that all connections in the circuit are tight and secure. Loose connections can cause resistance and voltage drop. In addition to the technical requirements of the NEC, it is also important to consider the practical aspects of electrical installations. For example, it is important to choose a location for the oven that is accessible and easy to service. It is also important to make sure that the oven is properly ventilated to prevent overheating. When installing the oven, it is important to follow the manufacturer's instructions carefully. This will help to ensure that the oven is installed safely and correctly. After the oven is installed, it is important to test it to make sure that it is operating properly. This includes checking the temperature of the oven and making sure that all of the controls are working correctly. If any problems are found, they should be corrected immediately. Regular maintenance is also important to ensure that the oven continues to operate safely and efficiently. This includes cleaning the oven regularly and checking the connections to make sure that they are tight and secure. If any problems are found, they should be corrected immediately. Finally, it is important to remember that electrical work can be dangerous. It is always best to consult with a qualified electrician before attempting any electrical work. Electricians have the knowledge and experience to ensure that electrical installations are done safely and correctly. To elaborate further on the importance of following manufacturers' recommendations, consider that appliances are designed and tested to operate within specific parameters. Deviating from these parameters, such as using an incorrect breaker size, can lead to unforeseen consequences. Manufacturers often conduct extensive testing to determine the optimal breaker size for their appliances. This testing takes into account factors such as the appliance's startup current, operating current, and potential for overload. The recommended breaker size is intended to provide adequate protection against overcurrent conditions without causing nuisance tripping. Nuisance tripping occurs when a breaker trips unnecessarily, interrupting the power supply to the appliance. Using a breaker that is too small can result in nuisance tripping, while using a breaker that is too large can compromise the appliance's protection. The manufacturer's recommendations are based on a thorough understanding of the appliance's characteristics and operating conditions. Following these recommendations is essential for ensuring the appliance's safe and reliable operation. In addition to the breaker size, the manufacturer's instructions may also specify other important information such as the recommended wiring method, grounding requirements, and ventilation requirements. It is important to follow all of the manufacturer's instructions carefully to ensure that the appliance is installed and operated safely and correctly. To further emphasize the potential hazards of using an oversized breaker, consider that an overcurrent condition can cause the conductors in the circuit to overheat. Overheating can damage the insulation on the conductors, leading to short circuits and ground faults. Short circuits and ground faults can cause electrical shock and fire hazards. An oversized breaker may not trip quickly enough to protect the conductors from overheating, increasing the risk of these hazards. The purpose of the breaker is to interrupt the circuit when an overcurrent condition occurs, preventing damage to the conductors and reducing the risk of fire. An oversized breaker may not provide adequate protection, allowing the conductors to overheat and potentially causing a fire. It is also important to consider the impact of an electrical fire on the building and its occupants. Electrical fires can spread quickly, causing significant damage to the building and its contents. They can also release toxic fumes, which can be harmful to the occupants. In some cases, electrical fires can even be fatal. Therefore, it is essential to take all necessary precautions to prevent electrical fires, including using the correct breaker size for appliances and equipment. In addition to the potential for electrical fires, oversized breakers can also damage appliances and equipment. Overcurrent conditions can cause damage to the internal components of appliances and equipment, such as motors, transformers, and electronic circuits. This damage can lead to premature failure of the appliance or equipment, resulting in costly repairs or replacements. An oversized breaker may not trip quickly enough to protect the appliance or equipment from overcurrent damage. Therefore, it is important to use the correct breaker size to protect appliances and equipment from damage. In summary, replacing the 50 amps breaker with a 40 amps breaker for the 7.2 kVA double-stacked oven is mandated by the NEC and is essential for ensuring electrical safety and preventing potential hazards. Following the manufacturer's recommendations and consulting with a qualified electrician are also important steps in ensuring a safe and reliable electrical installation.